Good evening, y'all, or good morning, wherever you are and what time you're watching. My name is Michael Robbins, and I will be presenting to you my web mapping final that I completed in the spring of 2020 at Temple University PSM Grad School. Some of the goals I have with this project are to plot the county level corona data in the Northeast region of the United States. I want to build an all-encompassing web app that allows you to hover over a county polygon, access data and its attributes, and I want to make it look nice by adding a state boundary layer, and I want to utilize a Google chart to display the changes in rate of infection. A few of the resources I used were both from GitHub, actually. One was from the New York Times. This is where I actually got the corona data from. I wrote corona date there. It should say data. Sorry about that. I've also used the Johns Hopkins data repository. Theirs is really well. Is very easy to use and very accurate, and it's very thorough and clean. I used the New York Times one because it was broken up by county and it was easier to use to join to a polygon layer. So that's why I chose New York Times. And I also just grabbed some shapefiles from another GitHub repository run by a guy named David Eldersfeld. I use Python to do a lot of data cleaning, QGIS to do some data joining and some additional cleaning, JavaScript to create some user interactivity for the maps. I house it all in an HTML document and use CSS to stylize. All right, well, let's go to our Python code first. I won't spend too much time on this, but just kind of want to go through it. Python has modules that I use. One's called OS, one is called Pandas. OS is to make it easier for someone to mimic my data analysis if they were to bring the repository local. And OS is a very useful way to navigate directories and subdirectories. So that's why if you would like to recreate this study on your own local machine, the only thing you need to change in this Python script is the base directory. I use OS to do everything else. So after we read in our CSV, which contains all the corona data on the county level. And we just want certain states. We want New York, New Jersey, Rhode Island, Massachusetts, Vermont, New Hampshire, Connecticut, Maine, Virginia, Maryland, West Virginia, Pennsylvania, Delaware, and the District of Columbia. So here's all the data now. The data here, some things to note is that every record is cumulative. So when you see 1 case, 0 deaths for Suffolk County, that is cumulative. So every day a data report is released, it is added to it. So you can see Suffolk County has 1 case throughout all of February. And then you can see here, when you go down to the last record, Wyoming, West Virginia, I guess Wyoming's a county, only has 1 record as of April 28th. The most up-to-date file I'm using is April 28th. All right, a few things about the data. For some reason, the New York Times decided to aggregate all the boroughs into 1 county. However, they didn't assign a FIPS code to that county. It's null. So I'm just going to choose the Manhattan FIPS code to represent all of New York City, so it's easier to join. Next, we only want, since the data is cumulative, we only want the last available data source so that we're not looking at multiple, we're looking at 1 county, one one cumulative caseload and one cumulative death load. And the way I did that is through this function. I'm not going to go too much into it, but basically it allows me to grab the most recent date for each county. A lot of data is accumulated but isn't assigned a county. So I just want to get rid of all of the data that's not associated by a county. So some additional data cleaning, won't go too much into it, but essentially we are going to export our CSV. We're going to export a CSV containing all the corona data by county. We're going to export a JSON to represent our data for our line graph we're going to create. So here is my QGIS document I'm using. I skipped over a few steps, but essentially I used a dissolve tool to dissolve all the counties to represent the states. And I also queried out all the additional counties we don't need. So when you downloaded the United States counties shapefile, it had every single county for every single state. We only want the ones that we discussed before. Some additional things I did were I joined all of so since the data I've received had each New York City borough highlighted as a county, and our CSV data doesn't have that, I used the editing toolbar and merged all of the counties together, assigned it a FIPS code of 36061. That way it's able to successfully join. Another quick thing I want to show you is that Baltimore and Baltimore County are, I essentially had to go and edit Baltimore County because both Baltimore and Baltimore County read as Baltimore. So I just wanted to fix that attribute quickly. So here is our CSV. If you look right here, using QGIS, I joined the CSV document to the county shapefile on the FIPS code. Next, we're going to go to our JavaScript or HTML file that houses our JavaScript. Quickly go through this. Here we have we are sourcing all of our leaflet functions through this line of code right here. So that's how we use our leaflet functions. And for our Google Charts, we are sourcing it right here. So I'm able to use Google Charts in this document. This is our CSS code. I make use of something called Flex, which allows you to display containers in a visually appealing way and fun and easy way. So that it's able to translate to a lot of different size computer screens, and it looks nice on the web page itself. This is our map CSS tag. This is where our map was going to go. Our chart div is the styling for a Google chart. All this stuff, info, legend, info one, are additional properties of the web page that need some styling. This is some text explaining some of the reasons why I did the map. I made use of span tags to source data into the text from a data table. That way, if I wanted to update this web page, I wouldn't have to manually type out some of the figures. I would just have it sourced, and it automatically updates based on where the span tag is. Here are 3 JSON documents: counties COVID, state boundaries, and Corona County's line graph. This is this is the source of where we're going to display our data. Right here is so one cool thing about the map. Let's actually go there right now. So this is actually not, this technically is in my GitHub page. I'll show that later. This is my local version of the map. But one thing is when you highlight a certain county, it shows you the attributes. 57 cases, 0 deaths for Penobscot in Maine. Around 162,000 cases for New York City. And you can see here how the color comes slightly darker, and you get a thicker border. And when you mouse out, the style resets. And that is due to these lines of code here. We reset the style and we bring it to the back. So another thing you want to see here is our state boundaries layer. So technically our state boundaries layer is on top of the counties. And my initial problem I had was that I wasn't able to select any of the counties because the boundaries layer was blocking them. So one way I fixed that was, oh no. There's a property for boundaries called interactive, and I labeled that false. And that enables me to select through the boundaries layer so I can access the counties. Another thing that was throwing us off was every time I unselected a state using this controller here, the counties would migrate on top of the boundary layer. And it's not that big of a deal, but it's a little bug that isn't visually appealing. Easy solution is just by selecting a certain county, and then you're able to since you have it resetting on every mouse out, it sends it to the back. However, when you add a layer on using the controller, it doesn't automatically send the county layers to the back. And the way I fix that is by using a map on function. If I could find it. When you have about 500 lines of code, sometimes things are pretty hard to find. Map.on. So I actually have it commented out for display purposes. But so there's this map on overlay add function that brings the boundaries to the front no matter what. So if I go ahead and save this, and I go and turn off New York, turn it back on, automatically the counties are sent to the back. Next, so here we go. So the thing I was talking about, having the span tags sourcing a data table. For the total cases and total deaths, I didn't write the numbers here automatically. I sourced them so that if I update this to a more update version of a document, it will automatically update. This is the Google chart. Here is it displays the rate of cases and the rate of death. And you can see here around day 60, 2 months into the pandemic, is when there was a sharp increase in the amount of cases. Whether this is a reporting scenario or if this actually was a spreading scenario is unclear. But around 2 months in, the Northeast started experiencing a lot more cases at a significantly higher rate. One thing I'm proud of about this web page is the use of the Flex CSS method. That's how I was able to group the map and the text box nice together, and then have the Google chart below them as the same width as the combined width of the top two containers, and it's kind of neatly displayed. I kind of want to add more to this page at some point, maybe another map, another chart, and add some more styling to make it look nicer. But yeah, thus far, just a good way of using Python, JavaScript, HTML, CSS, and QGIS to kind of look at corona data. That's all I have for today, guys. If you need anything else, just email me at my email address in the comment section or the information section of the video. And yeah, thanks so much for paying attention.